we have already looked at the parallelogram. Parallelogram, right? Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, right? We know that the diagonals bisect each other. There's probably something I'm forgetting, but general rules about that. Now we've got other kinds of quadrilaterals to talk about. We've got squares, we've got rectangles, we've got trapezoids, we've got the rhombus, and we've got the kite. Are there any of these shapes that this is the first time you're hearing those words? Good. Now, square and rectangle, those were what? Kindergarten? Nursery school? Right? So, we're pretty familiar with these. So we're just going to formalize that a little bit. Trapezoid, I think you've heard this. Yeah, right? So we're going to learn about that. Rhombus and kite, they might be a little bit different, but we're just going to go through that. So I'm telling you, this is not like really tough. It's just remembering the different properties. So I've got this nice little Venn diagram here, which shows the world of parallelograms. All these objects are actually parallelograms because all these objects, rectangles, rhombuses, squares, have opposite sides that are parallel. So they are parallelograms, but they're special parallelograms. A rhombus is a parallelogram where all the sides are congruent. Right? All of the sides are congruent. If that's true, then you have a rhombus. A rectangle is a parallelogram. Here it is. So it's a parallelogram, opposite sides parallel, with 4 right angles. Now I remember taking geometry and my teacher telling me, well, you only need to say there's 1 right angle. Why do I only have to say there's 1 right angle? It's a parallelogram with 1 right angle. So if I have a parallelogram with 1 right angle, what do I know about, say, the opposite angle? It has to be, right? Opposite angles are congruent to parallelogram. What do I know about the consecutives? They're supplementary, so if you add that, okay, so that has to be 90, 90 plus 90, so this one also. So you really only have to say that you have a parallelogram with 1 right angle. That's how they teach you in New York. Apparently in Virginia they teach you to say there's 4, but you really only have to say there's 1. A square is also a parallelogram. It has 4 congruent sides and 4 right angles. So a square is a rhombus because rhombuses have 4 congruent sides, and it's also a rectangle because of the right angles. So a square, see how it's kind of in the intersection of the rectangle and the rhombus. It's both of these. So it's got that going for it. So here's kind of a hierarchy if you want to look at it that way. If you start with a quadrilateral and you say something is a parallelogram, it's kind of like you can look up and it's going to be true. A parallelogram is a quadrilateral. A rectangle is a type of parallelogram. A rhombus is also a type of parallelogram. But now look at our square. It's both things. So it's kind of this nice little hierarchy to kind of show how we classify things. So if you say something is a rhombus, you can also say that thing is a parallelogram and that thing is a quadrilateral. Kind of works its way up. Does that make sense? Sometimes the pictures are a little bit easier. For some people, not so much. Yeah?
Can you say square is a parallelogram?
Yes, because you can follow all the way up. Yeah, absolutely. Because a square is a rectangle, and a rectangle is a parallelogram, and it's a little bit like the law of syllogism here, right? It's going to be that thing as well. Okay, good. Good question. Some corollaries. A quadrilateral is a rhombus if and only if it has 4 congruent sides. So again, what does the if and only if tell me? Yeah? Yeah, right. The inverse will be true as well. It's a biconditional. So if you have a quadrilateral with 4 congruent sides, it is a rhombus. A quadrilateral is a rectangle if and only if it has 4 right angles. And again, if and only if. So if you have something with 4 right angles, a quadrilateral with 4 right angles, it's going to be a rectangle. And the rhombus, or the square. The square, quadrilateral is a square if and only if it's a rhombus and a rectangle. And if a quadrilateral is both a rhombus and a rectangle, then it is a square. So again, biconditionals. You have one, you have the other. Some properties now. Here's some properties of a rhombus. Remember, these will have all the properties of a parallelogram because they are parallelograms. And these extra ones, depending on what it is. So it's going to be true, opposite sides parallel, opposite angles congruent, you know, all those things are going to be true. What else do you have? 4 congruent sides, that's its definition. The diagonals, so let's draw a diagonal. They bisect the angles, so what does that mean about, like, say, this one and this one? The diagonals bisect the angles, what do I know about these two things? Congruent. What do I know about these two? Oops. Congruent, right? So that's what I mean by bisecting angles. And not only that, the diagonals are perpendicular. So if you draw the two diagonals, they are always going to be these right angles. So things to remember about a rhombus. A rectangle, well, by definition, we have 4 right angles, and the diagonals are congruent. That's all we can say about them. So what do you think we can say about a square then? If a square is both a rhombus and a rectangle, what are we going to say about a square? Yeah. Yeah, exactly. All of these things are going to be true for the square because it's both a rhombus and a rectangle. So it's got everything that's true about a rhombus, that's these 3, and it's got everything that's true about a rectangle, that's the bottom 2. So all the properties are true for a square. So these are examples here. Given rhombus DEFG, are the statements sometimes, always, or never true? So here's a picture of a rhombus. Is angle D always, sometimes, or never congruent to angle F?
Always.
Always. How come? Because? It's a parallelogram. It's a rhombus. When rhombuses are parallelograms, the opposite angles are congruent. How about angle D congruent to angle E? Sometimes, always, never?
Sometimes.
Sometimes? Why not always? Right? You can have, right? Why not?
Because there's supplementary, so must be square and both sides.
There we go. Okay, so she said they're supplementary. So that would mean that the only way they can be congruent is if they're both 90. What kind of parallelogram has 90-degree angles? What do you think, Elizabeth? Square. Do I know it's guaranteed to be a square? Well, if it's a rhombus, it is. So this is a sometimes. It can be, but not always. How about DG being congruent to GF? If this is a rhombus, what do I know about, yes? Always. That's right. Definition of a rhombus is a parallelogram with a congruent side. So again, thinking about the different properties. So let's see here. Let's classify this parallelogram and find the z-values. If you're looking on your notes, we're on the bottom here. It's number 2. Okay, so let's see. I see 4 congruent sides. So what is this? What? A rhombus. How do I know it's a parallelogram? Well, if opposite sides are congruent, it's a parallelogram. And since they're all congruent, the opposite sides are those. And all of them congruent make it a rhombus. Okay, so let's see. How can I find the value of x? Did you guys, did you leave the room? How do I know, how do I find x? Why? Right, rhombus, all the sides are congruent, their measures have to be equal. 3x equals 6, so x must be 2, right? How about finding y? How am I going to do that? What do you think, Rachel? Good. It's a parallelogram, which means consecutive angles are supplementary, so we can just go and see that out here. That's what, -6 plus 12y is 180. What's 180 minus 96? I want to say 84? All right? Not good in my head here. Divide 84 by 12. What did I get? 7? 7?
Yes.
X is 2 and y is 7. All right, this thing, now what is this? This is a parallelogram. What is it? What is it? A square. How do I know it's a square? I've got the 4 right angles. I've also got counterpoint sides. How am I going to find x? How do I find x? So what equal to each other? Yes, because these sides are equal. So what am I getting here? 2x equals 8? So x is 4. I hope I'm doing it right. I'm going a little fast here, so stop me if I make a mistake. How am I going to find y? How am I going to find y?
7y plus 3 equals 90.
Well, it's this little piece right here. Now the whole thing is 90. What's this little piece? Jake, what do you think?
7y plus 3 equals 45.
How do I know it's half? Because a square is a rhombus, right? And what do I know about the angles of a rhombus? Diagonals bisect the angles. They bisect the angles. So if this whole thing is 90, then it must be 45. So 7y equals 42, y equals 6. So just, again, using the properties to find different values. What else? Okay, so I've got a rhombus. Right away, when I see rhombus, I got to do this. It's just, it helps me find different things. Measure of angle xzy, that's this thing right here, is 34 degrees. Find, let's see, WZV, that's this one. Gee, what's that going to be? Yeah? Look again at properties of a rhombus. This actually is an easy one if you know your properties, which you just learned them. So look at the notes for a rhombus. What do I know about this angle and its diagonal? What do I know? What do I know, Sam? Yeah, so what's the value here? 30, 40, it's just going to be the same. How about WY? How am I going to find that guy? Yeah? 14, how come? Right, it's a parallelogram, so because it's a parallelogram, the diagonals bisect each other. If this one's 7, so is that one. And now I want XY. Ooh, that's this guy. This one, you have to think a little bit. I'm going to give you a hint here. What do I know about the diagonals here? What do they form in the center? A right angle, right? They're perpendicular. So I got that. What else do I kind of know? If this is 34 and 34, so this whole thing is 68, right? What's this whole thing going to be? This whole angle here? How'd you get that? Yeah, supplementary. So 180 minus 68, take your word for it. 112. So then what are each little piece here? What's half of 112? It is? It is 56, right? 56? So let me just pull this little triangle out here. 56 degrees. Got that. And I'm trying to find this, right? I got this one. Okay. How do I find? I have a right triangle. I know some angles. I don't know a side. How do I do it? Trigonometry. So what can I do here? Let's pick this angle. How about this angle? Relative to this angle, what do I know about x? Yes. Do I know anything? Sine? Cosine. Cosine of 56. And I know this one's 7, right? Equals 7 over x. Which means what? That x equals 7 over cosine 56. Doesn't it? So now, I need a calculator. What's the first thing you're doing to your calculator? Check that. Well, turning it on. After you turn it on, mode. And make sure you are in degrees. Good. And then what do I want? 7 divided by cosine 56 minus x raised to d. Approximately 12.5. Yeah, you still have to know trig? Yeah. Yes. Okay, relative to this angle, this is my adjacent side. Oh, right? and this is my hypotenuse. It's opposite to 90, adjacent over hypotenuse. Oh, goodness gracious. Yes?
And I just want to tell you that
How I got what, 34? In a rhombus, the diagonals bisect the angles. So if this little piece is 34, then this little piece has to be 34, because they bisect the angles. All right, this is a rectangle. Angle RPS is 62. QS, well, there's QS. That's this whole diagonal is 18. Find these different things. Now, it's 18. Sometimes that's hard to write. You know what I'm going to do here? I think I'll write it in this way. I know they bisect each other, and it's a little bit clearer what measure is what. I want to find QPR. QPR. What's this? Yes, what's that going to be? 28. How'd you get that?
90 degrees.
Yes, it's a rectangle. That means this is 90 degrees. If this piece is 62, 90 minus 62, he tells me that's 28 degrees. PTQ. This guy. Well, what's that going to be? Now let's think a little bit here. Yeah, what do you think it's going to be? Well, let's put it this way. What's this one? What's this angle? The whole thing. Well, the whole thing is 90. And then
That one's
this one's 62 or this one. Now let's think about this. These are my diagonals. The diagonals in a rectangle are congruent. So what's this piece and this piece? So they're both 9, right? This is an equilateral triangle. If one of the base angles is 28, what's the other one? 28. If these two are 28, can I find this one? Right? Triangle sum theorem, 180 minus 28 minus 28. I did all that. What did I get? 124. In here. So we're using all these little bits of information. ST, well, we've done that, right? ST is just 9. Half the diagonal. So we're putting together just a lot of different things that we hopefully know. Cool. What else? Oh, look at trapezoid. A trapezoid, that's a quadrilateral as well. And it's got one and only one pair of parallel sides. So I see some parallel sides. If these are parallel and these are not, you have a trapezoid. So parallelograms are not trapezoids because both sides are parallel. So one is and one isn't. What else do we know? Mid-segment, sometimes called the median of a trapezoid, is you look at the non-parallel sides, you find their midpoints, and you connect them. That's a mid-segment of a trapezoid. And then an isosceles trapezoid is you take those non-parallel sides and they're congruent. And that is called an isosceles trapezoid. So different things to know about trapezoids. Some theorems. If a trapezoid is isosceles, meaning the non-parallel sides are congruent, you get two sets of base angles, and both of those sets are congruent now to each other, but it's not necessarily four congruent angles. So the bottom base angles are congruent to each other, and those top base angles are going to be congruent. If a trapezoid has a pair of congruent base angles, so if you know it's a trapezoid, and you find that these angles are congruent, then it must be that these sides are also congruent. It's isosceles. The trapezoid is isosceles, if and only if, so again, biconditional. The diagonals are congruent. So if you have an isosceles trapezoid, diagonals will be congruent. If you have a trapezoid with diagonals that are congruent, it is isosceles. And the midsegment. The midsegment is parallel to the parallel sides, and its length is 1/2 the sum of the length of the bases. Oh. So if this length is A, and this length is B, and this is length C, C would be 1/2 A plus B. Basically, you're averaging the two bases to get this length. All right, so that's all our trapezoid find. So let's see if we can do a couple of examples. What do I have here? Ooh, look at that one. I'm trying to see if this is on your paper. It's not on there, is it? Oh, yes, it is. I just didn't give you the graph. This is example A. So it's giving you the vertices of a trapezoid. You may want to sketch these. I didn't include that. I didn't have room there. So let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. B is 1, 1, 2, 3. C is at the origin. And D is negative 70. 1, 2, 3, 4, 5, 7. Well, is it or isn't it? How do we know? How can I show? How do I prove that this is a trapezoid? How do I do that? Well, have the length going to help me? What do I want here, Natalie?
Slope.
Slope. Why is slope going to help me? So how do I know if lines are parallel? Right? Same slope means parallel lines. So let's look at the slopes here. Looks like 1 down, 2 to the right. Right? It's negative slope. So this one looks like negative a half. Let's see, what's this one here? 1, 2, 3, 1. This one looks like a slope of 3. I'm just counting boxes. Is this a mystery to anybody what I'm doing? That's also got a slope of 3. And what's the slope of a perfectly horizontal line? Yeah? 0. So is this a trapezoid? Yes, because AD is parallel to BC because their slopes are the same. So here's one set of parallel sides, but AB is not parallel to CD because their slopes are not the same. So this is a trapezoid for that reason. So slopes come in handy. Find angle B, that's this guy, and PQ, which is this. How am I going to do that? Do I know that opposite angle? These aren't parallelograms. I can't just assume they're congruent. What do I know, though, Owen? It's isosceles. So how does that help me? Okay. But they want angle B. Now, look, notice how these are parallel lines, and this is a bisector, or I'm sorry, a transversal. So what do I know about these two? Right? If you have a transversal with parallel lines, what do I know about consecutive interior angles? They are supplementary. So now I have to do 180 minus 75? 105? And if this is 105, what's this one? Also 105 because it's isosceles. But they only want the measure of angle B, appears to be 105 degrees. And then PQ. How am I going to find PQ? That way. How am I going to do that, Kayla?
Add up the bases and divide it by 2.
Yep. That's that, the other theorem that we had. 25 plus 35, 60? Take half of that? 30. So PQ is 30. It's the average of the two, right? Isn't the average 25, 35, 30? It sure is. All right. What else? Kites. Let's go. Anybody see Saving Mr. Banks? Oh, wasn't that great?
No.
And they were singing Let's Go Fly.
Slow.
I love that movie. Okay. Go see it. It's about Walt Disney trying to convince P.L. Travers, who wrote Mary Poppins, to make the movie, and she's not real into it. So they sing that song, Let's Go Fly a Kite. So that's what made me think of it. So anyway, go watch Mary Poppins again. Do it. What's Mary Poppins? A kite is a quadrilateral, another four-sided figure. All right. I didn't know you could sing so well, Nathan. That's awesome. All right. Here's what's interesting about a kite. It has two sets of congruent sides, but they're not opposite. They're consecutive, meaning next to. So you've got these two are going to be congruent, and these two are going to be congruent. If you have a quadrilateral with this situation, you have a kite. So what are my theorems that go with kites? Not too many. Just like in a which other figure has the diagonals being perpendicular? Which other one? Rhombus. So just like the rhombus, the diagonals are perpendicular to each other. And there is exactly one pair of opposite angles, and they are in between the two non-congruent sides. So here and here, not congruent. Here and here, congruent. So the two in between the two non-congruent sides, you have congruent opposite angles. Okay, so examples. Can I find the measures of Q and S in this kite? Given that it's a kite, so I know this, it's a kite. Can I find, what do I know about these two? They're the same. So if this is X, this one's X. What do I know about, what do they all add up to? 360, so 83 plus 41 plus X plus X, right? Two X's is going to give me 360. Oh, let's see. What's 83 plus 41? That's a 128? Yeah, 124. Subtract that, 124. This is 236. Take your word for it, divide by 2. That's a 1, that's a 118. So these are 118 degrees. What else can we do? Find the missing lengths of the kite. Now I know this is congruent to that. I know this is congruent to that. What do I know about the angle here? The right angle. So just looking at this triangle here to find XY, say. So 3 and 3, what do I know about these two? What is the measure of these two? The shield? I got a 45, 45, 90. How do I find the hypotenuse if I know the side? Yeah? 3 radical 2. Remember that? You mean this stuff does not go away? No. No, it does not. So that was easy, because we know that special triangle, at least I hope we do. Now let's look at this right triangle. I've got a 3, I've got a 5, I've got this. That doesn't sound like a triple to me. So using the Pythagorean theorem, 3 squared plus 5 squared is square root of 34. Square root of 34, what is that? That's, trying to think about how many perfect squares in there. No, I don't think I do. Square root of 34. That would be this one. And then, find all the other ones. Since that one's square root of 34, so is this one, because of the congruence angle of that height. So, yeah. And now we're trying it. Let's see, what's yeah, we can do these retries. There's 4 of them here. So you want to keep your properties handy, your theorems handy, and give these a try. These on here for facility. What we got here, X is 7, X is 9 for A and B. We got, let's see, I got 60, is that right? Okay. And how we do this? You say 150 plus 90, right? Is 240. Now all of it adds up to 360. So 360 minus 240 is 120, right? And that's these two angles, but these two angles are congruent, so you just divide by 2. And then this one, you're just doing the magic of right triangles. So I just used the Pythagorean theorem. This one came out to square root of 125, which is 25 times 5, 25 by 5. And this one also, I just did the square root of 19 squared plus 10 squared. And I got that. Questions? So it's not like this is so crazy difficult, but it is, you have to know your properties. I guess I should show you the hierarchy chart now with all the little pieces we talked about. So this is the quadrilateral family. We've got kind of 3 categories. You've got a parallelogram, trapezoid, and kite. Kite kind of dead end. We don't have any specialized kites. We do have a specialized trapezoid, the isosceles trapezoid. So this is a trapezoid, and this is a quadrilateral. And then we're going back to the one we already looked at. So just kind of, as a picture, how they all kind of fit together. So I just wanted to show you. So given these different types of quadrilaterals, how do I know what I have? And we did this actually a little bit with the other stuff. Now this came out terrible on your paper. None of the lines actually copied, but they're all supposed to be there. This is actually on your notes, right? They're very faint. They're hard to see. But this is a nice little thing to have. You can either darken them or just be very good that you put them in columns. So this little thing here means parallelogram. So just take a minute, see if you can actually do this. Fill in the chart by placing a check mark in the box for the quadrilateral where the properties, and like the first one, like all sides are congruent. Is that true for a parallelogram? Is it? All sides are congruent? Not necessarily, so don't check that. Is that true for a rectangle? Are all sides congruent in a rectangle all the time? No. How about a rhombus? Yes. How about a square? Yes. How about a kite? No. Right? So you get the idea? So take a few moments, think about, and you can look, use as reference the other paper for the different properties. Some of us still working on this. Let's see. Here's what I got. Let's see how we compare. What? Is that an uh-oh? Right? Both pairs of opposite sides are congruent. Well, once you check the parallelogram box, you have to check everything else that is parallelogram, right? Rectangle, rhombus, square. If this box is checked, so are these three boxes, because all these things are parallelogram. Pairs of opposite sides are parallel. Well, that's got to be true for all of them if it's true for the parallelogram. Exactly one pair of opposite sides are parallel. That is only true for a trapezoid. If there's only one. All the angles are congruent. Only true for rectangles and squares. Exactly one pair of opposite angles are congruent. One pair of opposite angles. That's only at the kite. That's the only one that got only one set of congruents. The diagonals are perpendicular. The rhombus, the square, and the kite. Because once you check that rhombus box, you have to check the square box. Because squares are rhombuses. Diagonals are congruent. That's true for a rectangle. But once you check that rectangle box, you have to check the square box because it's a rectangle. The diagonals bisect each other. That's a characteristic of a parallelogram, which means the other parallelograms will also be checked. So I think that the hierarchy I just showed you a moment ago is kind of a nice little picture to have, because if you know something's a parallelogram, then all its characteristics become true. Okay. So now what the idea is, so knowing all that, can we give the most specific name? And again, when you think of the hierarchy, how low can you go? So I know it's a quadrilateral, it has 4 sides. What else can I say about it? What else can I say? It's a square? Why do you say that? Because it looks like it? Okay, why did you change your mind? Great. Now he's noticing all the sides are congruent. Because this is a quadrilateral, that's 360 degrees. So then these all have to be right angles. So that makes it either a rectangle or square. We don't know if the sides are all congruent. So the best we can do is say it's a rectangle because all the angles are congruent. Now let's look at our friend over here. What do you think about B? What do you think? Around this, how come? Okay, so we have bisecting diagonals, which means parallelogram of some sort, and it has a perpendicular. So definitely rhombus, but is it a square? We don't know. Well, are they going to be? I do have bisecting diagonals, so I know it's a parallelogram. So I know that everything that's true of a parallelogram will be true for this. I do know it's a rhombus because it's perpendicular, but can I go further and say it's a square? What do I know about the diagonals themselves? Yeah? They will, because it's a rhombus, yeah?
Since all of the bisecting that each other, the diagonals are also
Diagonals are congruent, and that's true for a square, a rectangle, and it's a rectangle and a rhombus. It's two things, so this is going to be a square. Because the diagonals are perpendicular and they're congruent, it's actually a square. Oh boy. Hey, what about this thing? What do you think? It's a rectangle, how come? Well, how do I know that? I know these are supplementary, right? Do I know these are supplementary? What would I have to know? I have to know that these two are parallel. Do I know that? I don't know that. Yeah.
Well, they're kind of their alternate interior angles.
That would be out here and out here. Yeah.
It's not isosceles triangle.
Isosceles
Or not triangle.
as trapezoid?
Trapezoid.
Why?
Because it has one pair of base angles and one pair of parallel sides.
Right. So I have one pair of parallel sides. This I do not know if it's parallel. And these are congruent. So I also said isosceles trapezoid. One pair of parallel sides and one set of base angles that are congruent. So yeah, it can be a little tricky. You kind of have to run through like all those little checklists. You know, is that true? What do I know? So that can be a little tricky. Let's see, oh, what's this thing? Why, Thomas? You can say it out loud, it's okay.
Wait,
Wait for it.
yeah, so, because all the angles are 90 degrees.
All of them have to be 90 because this is parallel, right? So these are consecutive interiors. If they're going to be supplementary, if one is 90, so is the other. Well, it's a rectangle. Can it be a square?
Yeah, well,
Well, I don't know, right? We don't know that they're all congruent, so I can't say positively this is a square. The best I can do is the rectangle based on those right angles. What about this guy? What's the best I can do with him? What do you think? What do you think?
There's the diagonal 5 centimeters.
Well, that's true on any parallelogram, isn't it? What's special about the rhombus? The rhombus would say it's a right angle. Do I know that? I don't know that, so I can't really say if it's a rhombus. What do you think? What do you think, Maria? Parallelogram. How come? All I know about this quadrilateral is that the diagonals bisect each other. The best I can do is say a parallelogram. There's no other facts here that I can use. Good, very nice. What about this last person here? They're people too. What's this thing? What do you think we should do first here, Rachel? Before we decide for sure. If there's one thing I would do first, before she has an answer, so I just want you to consider one thing first before you say it. Or you can say it. What do you think it is? Why? Right, so these aren't congruent. I need to figure out if something is parallel, right? I need to figure that out. How can I do that? Based on what I know. Well, I think the first thing you want to do is, what's angle B, right? Can I find angle B? If the whole thing is 360, and I know 3 of the angles, what's the fourth angle? What is it? 129. 129? Okay. How does that help me? Can I figure out if I have any parallel lines? Well, what do I know about consecutive interior angles and parallel lines? They add up to 180. Now, this way they don't add up to 180. These are definitely not parallel lines. What about this way? What's 119 and 61? Come on, 129 plus 51. 180. So what do I know about these two? They are parallel because if you have consecutive interior angles and they are supplementary, then you have parallel lines. These are not. So what can I say this is? It's a trapezoid. Because you have one pair of parallel sides, because we can see the consecutive interior angles, and we have one pair of not parallel sides. So, wow, we got to use a lot of stuff here. Another way to kind of do some identifying of quadrilaterals is they're going to say this, the best you can do is parallelogram. Agree or disagree? Wait, what? You agree?
Agree.
Was that you, Andrew? Somebody said agree. Is that you? No? Somebody did. Alrighty, so why? Why do you agree with that?
all the things that the opposite.
Yeah, all I know is it's a quadrilateral where opposite sides are congruent. The best I can do is say it's a parallelogram. Square, is that the best I can do? Yeah, right? I've got 4 right angles and the sides are congruent. Trapezoid, is that the best I can do? No, what else can I say? Well, just a minute. Don't know if one pair of sides is parallel. Can I create a quadrilateral with two congruent sides here? What if I made this picture look more like this? Oh, I can't draw with this thing. Would you say it's a trapezoid now? It's a horrible picture. It's like this was a little bit tilted, and this went straight up. So again, don't go by looks. Can we see a quadrilateral where I don't have a pair of parallel sides, but I do have some congruent angles? So I don't necessarily know it's a trapezoid. So try to remember this. Don't go by what it looks like. Is this a rhombus? What do you think?
No,
Well, I don't know if they're, but is it enough to know that they're perpendicular diagonals?
Yes.
Well, isn't there another shape? Yeah. It could be a kite. Kites also have that. So I don't know for sure that's a rhombus. Isosceles trapezoid. Well, this part looks good. And let's see. Well, what's this angle? You know, whenever they give you three, find the other. Because that'll give you something, some more information. What's that last angle? Yes. These are not supplementary, not parallel. These are not supplementary, not parallel. So it's not an isosceles trapezoid. If you would put this in, you can do the same thing and just play, adding them up, that they don't add up, they're not supplementary. So we don't know. So we don't have enough information. Can I positively conclude this is a square? What do you think? What do you think? We don't know if all the sides are congruent. What about the information about the diagonals? Yeah. Right. So no, I said it could be a rectangle, which I think, and it kind of goes along with what both of you said, is I don't know enough about the sides, and also these, what's going on with these diagonals. So I don't know. And so the U-tries are basically kind of working with this idea of, what do we know, what do we don't know about these quadrilaterals. And so try these U-tries, there's 4 of them, and see what we can figure out here. Right? I know all the sides are congruent, but I don't know if the angles are right, so the best I can do is run this. This quadrilateral I'm saying is a kite because I've got 2 congruent consecutive sides. That's pretty much a definition of a kite. Is there enough information to show that this is an isosceles trapezoid? Well, I did go and I subtracted 360 minus these angles. I get 78 degrees there. They add up to 180 this way, but not that way. So it is a trapezoid, and I see these congruent based angles, so I know this is an isosceles trapezoid. This guy here, do I know that this is a rectangle? Yes, I do. If I have 3 right angles, I have 4 right